Hi everyone, welcome back to Technical Mathematics. In this lecture, we will discuss binomial theorem. We will discuss basics of binomial theorem and we will try to solve few problems related to binomial theorem. Okay, so before proceeding with binomial theorem, let's have a look at combination. What do you mean by combination? A combination is a selection of items from a collection. So it is denoted as NCR. And the formula is NCR is equal to n factorial divided by r factorial into n minus r factorial. So here NCR is number of combinations, n is total number of objects in the set, and r represents number of choosing objects from the set. Now let's see how to calculate combination values while doing problems. We know that NCR is equal to n factorial by r factorial into n minus r factorial. But this equation involves 3 factorials, which makes calculation time consuming. So let's see an alternate equation. Here n factorial can be expanded like this: n into n minus 1 into n minus 2 etc. n minus r plus 1 into n minus r factorial. Now in the denominator we have r factorial into n minus r factorial. So n minus r factorial comes as a common term in both numerator and denominator. So we may cancel that. Okay. Resulting equation is this one. Okay, so we will be using this equation to calculate combination values while doing problems. Let's see an example. Suppose we need to calculate 6C3. 6C3, here n value is 6. Okay, and r value is 3, and n minus r plus 1 is the lowest value in the numerator, so that will be equal to 6 minus 3 plus 1, so it's equal to 4. Okay, so here 6C3 will be equal to 6, which is n into n minus 1, that is 5 into, okay, the next value will be 4. Okay, so n minus r plus 1 is 4, so numerator term ends with this 4. Okay, that one divided by denominator will be nothing but 3 factorial. So 3 factorial is 1 into 2 into 3. Okay, so this gives us the value of 6C3. So you can see that here we have a ratio of 2 product terms. The product term in the numerator starts with n value and descends downward, okay, up to 4. Okay, we are having 3 terms here. So r value, if it is 3, we will have 3 terms in the product. Similarly, in the denominator also, we will have 3 numbers in the product term. Okay, so in the denominator, it starts with 1, then it goes in the ascending order, 1 into 2 into 3. So this one is actually 3 factorial. Okay, so this is how we calculate combination values when we do problems. We won't be using this factorial expression. It is easier and time saving if we go for this alternate equation. Okay, now if we calculate this, we will get the value. Okay, 2 into 3 is 6, so that 6 and this 6 can be cancelled. Now remaining are 5 into 4, so value is 20. Now let's see one relation corresponding to combination. NCR1 is equal to NCR2 if R1 plus R2 is equal to n. Let's see an example. 5C2 will be equal to 5C3, because here in place of R1 we have 2 and in place of R2 we are having 3. So when you add these two, 2 plus 3, we get 5. Okay, and let's see what is the value of 5C2. 5C2 will be equal to 5 into 4 divided by 1 into 2. So the value will be 20 by 2, that is 10. Now 5C3, its value will be 5 into 4 into 3 divided by 1 into 2 into 3. So this value will be, again, we will get it as 5 into 4 divided by 1 into 2, that is 20 by 2, that is 10. So you can see that the value of both these combinations are equal. So that is what this relation says. NCR1 will be equal to NCR2 if R1 plus R2 is equal to n. So this identity is also useful while doing problems. Okay, so we discussed what is combination and we discussed its formula and also we discussed one identity related to combination. Now we will move on to binomial theorem. We know that a binomial is a polynomial that is the sum of two terms. Here in this case we have a plus b whole square. A and b are two monomials, or this expression a plus b can be considered as a binomial. So it is sum of two terms. So a plus b whole square, we know the expansion, it is the most familiar equation. A plus b whole square is equal to a square plus 2ab plus b square. So here coefficients are 1, 2 and 1. Coefficient of a square is 1, coefficient of ab, the second term, is 2, and the coefficient of b square is 1. So coefficients are 1, 2 and 1. Now these coefficients can be represented in terms of combinations like this: 2c0, 2c1 and 2c2. So let's rewrite this expression in terms of combination values. Let's say a plus b whole square is equal to 2c0 a raised to 2 b raised to 0 plus 2c1 a raised to 1 b raised to 1 plus 2c2 a raised to 0 b raised to 2. Okay, now let's consider a plus b whole cube. A plus b whole cube is equal to a cube plus 3a square b plus 3ab square plus b cube. Now here coefficients are 1, 3, 3 and 1. You can see that here coefficient of a cube is 1, the second term is having a coefficient of 3, and the third term is having again a coefficient of 3 itself, and b cube term is having a coefficient of 1. And these coefficients can be represented like this: 3c0, 3c1, 3c2 and 3c3. Okay, so let's try to write this expression in terms of combinations. A plus b whole cube can be written as 3c0 a cube b raised to 0 plus 3c1 a raised to 2 b raised to 1 plus 3c2 a raised to 1 b raised to 2 plus 3c3 a raised to 0 b raised to 3. Okay, now let's consider a plus b whole raised to 4. Now a plus b whole raised to 4 is equal to a raised to 4 plus 4a cube b plus 6a square b square plus 4ab cube plus b raised to 4. Here coefficients are 1, 4, 6, 4 and 1. Okay, now we may rewrite these coefficients in terms of combination values like this. We may represent 1 as 4c0, 4 as 4c1, 6 as 4c2, 4 as 4c3 and 1 as 4c4. So let's rewrite this expression in terms of combination values. A plus b whole raised to 4 is equal to 4c0 a raised to 4 b raised to 0 plus 4c1 a raised to 3 b raised to 1 plus 4c2 a raised to 2 b raised to 2 plus 4c3 a raised to 1 b raised to 3 plus 4c4 a raised to 0 b raised to 4. Okay, so we have written expansion of a plus b square, a plus b whole cube and a plus b raised to 4 in terms of combination values. Okay, now let's have a look at Pascal's triangle. So in Pascal's triangle we have a set of rows. As we descend down the Pascal's triangle, you can see that the number of coefficients increases. Here the first row corresponds to a plus b whole square. Okay, so coefficients of the expansion a plus b whole square is written here 1, 2, 1. Now the second row corresponds to a plus b whole cube. The coefficients of the expansion of a plus b whole cube is written here, and the third row consists of a plus b whole raised to 4. the coefficients of a plus b whole raised to 4 is written here. Okay, so we can derive the coefficients of a plus b whole raised to 5 from this triangle. Here you can see that each row starts with a 1 and ends with a 1. So here this row corresponding to a plus b whole raised to 5 will also begin with a 1. The second coefficient can be derived from these two. Okay, 1 plus 4 will give us 5. Then 4 plus 6 will give us the value of third coefficient, it will be 10. Then 6 plus 4 will give us 10, that will be the fourth coefficient, and 4 plus 1 gives us 5, which will be the fifth coefficient, and the last coefficient will be 1. Okay, so here the peculiarity of Pascal's triangle is that each row will start with a 1 and ends with a 1, and the coefficients in the next row can be derived from the previous row. Here when you add 1 with 2 we get 3. Here when you add 2 with 1 we get this 3. So likewise here also when you add 1 with 3 you get this 4. When you add these two 3's we get 6. When we add 3 with 1 we get 4. Okay, so this way values of coefficients can be derived from the coefficients of previous row. Okay, now if we expand a plus b whole raised to 5, what we get will be a raised to 5. The coefficient of a raised to 5 will be 1, that is this one. Okay, plus 5 a raised to 4 b raised to 1 plus 10 a raised to 3 b square plus 10 a raised to 2 b cube plus 5 a b raised to 4 plus b raised to 5. So this will be the expansion corresponding to a plus b whole raised to 5. Now if you write these coefficients in terms of combination values, we may write a plus b whole raised to 5 as a plus b whole raised to c naught a raised to 5 b raised to 0 plus 5 c1 a raised to 4 b raised to 1 plus 5 c2 a raised to 3 b raised to 2 plus 5 c3 a raised to 2 b raised to 3 plus 5 c4 a raised to 1 b raised to 4 plus 5 c5 a raised to 0 b raised to 5. Okay, now if we consider a plus b whole raised to n, in general whatever be the value of n, what will be a plus b whole raised to n? Let's see what it will be. The nth power of a binomial can be written as a plus b whole raised to n equal to n c naught a raised to n minus 0 b raised to 0 plus n c1 a raised to n minus 1 b raised to 1 plus n c2 a raised to n minus 2 b raised to 2 plus etc. plus n c r minus 1 a raised to n minus r minus 1 into b raised to r minus 1 plus etc. plus n c n a raised to n minus n into b raised to n. Now if we simplify this, we get a formula, a general expression for a plus b whole raised to n, that is equal to a raised to n plus n c1 a raised to n minus 1 b raised to 1 plus n c2 a raised to n minus 2 b raised to 2 plus etc. plus n c r minus 1 a raised to n minus r minus 1 into b raised to r minus 1 plus etc. plus b raised to n. Now here nc r minus 1 a raised to n minus r minus 1 b raised to r minus 1 is the rth term. So this term what we have here is the rth term in the binomial expansion. Okay, now here in total we will have n plus 1 terms. N plus 1 terms. Okay, and also you can see that the peculiarity of each of these terms is that the powers of a and b, when we add those two, we will get n. So here the first term is a raised to n. So here the power of a is n and power of b is 0, b raised to 0. So n plus 0, we have n. Now in this second term, here the power of a is n minus 1. n minus 1 plus the power of b is 1. So n minus 1 plus 1. The value is again n. So likewise, each of the terms present in this expansion has got powers of a and b. When we add those two, we will get n. So these three things can be considered as features of this binomial theorem. Rth term is this one. The expansion has got n plus 1 terms, and each of the terms present in the expansion has powers of a and b added to a value equal to n. Now let's see these features one by one. The first one says the expansion has n plus 1 terms. Second one, the rth term in the expansion a plus b whole raised to n is nc r minus 1 a raised to n minus r minus 1 into b raised to r minus 1. Okay. Now the third one says sum of powers of a and b is always n. Sum of powers of a and b is always n. Okay. Now let's see two results related to binomial theorem. The rth term, we already discussed this one. Rth term is equal to nc r minus 1 a raised to n minus r minus 1 b raised to r minus 1. So this is very important, the expression of rth term in the binomial expansion. Okay, now here if n is even, then middle term is n by 2 plus 1th term. The middle term will be n by 2 plus 1th term. And if n is odd, then there are two middle terms, n plus 1 by 2th term and n plus 1 by 2 plus 1th term. Okay, so we are having two middle terms when n is odd. Okay, so these 2 points are very important. So please make note of this. Okay, now let's do few problems based on whatever we learned. Let's see problem number 1. Find the coefficient of x raised to 6, y raised to 3 in the expansion of x plus 2y whole raised to 9. So we are asked to calculate coefficient of x raised to 6, y raised to 3. So for that, let's see what is the rth term in the expansion. Rth term will be 9c r minus 1 x raised to 9 minus r minus 1 2y raised to r minus 1. Okay, so we are asked to calculate coefficient of x raised to 6, y raised to 3. So in that term, the power of x is 6. So here for the rth term, the power of x is 9 minus r minus 1. So 9 minus r minus 1 should be equal to 6 for that particular term. So from this we can obtain the value of r. So here 9 minus 6 will be equal to r minus 1. This implies that r will be equal to 9 minus 6 is 3. So this is 3. R minus 1 equal to 3 implies that r is 4. The value of r is 4. So we are asked to calculate coefficient of the fourth term. Okay. Now fourth term can be written like this. We can derive the fourth term expression from this one. Fourth term will be 9c 4 minus 1, that is 3, 9c3 x raised to 9 minus 4 minus 1. So that is 9 minus 3, that is 6, x raised to 6, 2y raised to 4 minus 1, that is 2y raised to 3. So 2y raised to 3. Okay, so from this we may derive the coefficient of x raised to 6, y raised to 3. So that coefficient will be 9c3 into 2 raised to 3. So here we have 2 raised to y whole raised to 3. So from that we may take out the constant term 2 raised to 3 outside. So here we will get the coefficient value as 9c3 into 2 raised to 3. So here left out parameters are x raised to 6, y raised to 3. Okay, so once we simplify this, we will get the answer as 672. 9c2 into 2 raised to 3. We will get the value as 672. Therefore, here answer is option B. Problem number 2. Find the term independent of x in the expansion of 3 by 2 x square plus 1 by 3 x whole raised to 6. Okay, now to find the term independent of x, we must know the rth term in the expansion. So the rth term in the expansion will be 6cr minus 1 3 by 2 x square whole raised to 6 minus r minus 1 into 1 by 3x whole raised to r minus 1. So this is the rth term in the expansion. Okay, now let's try to combine the x terms, and let's try to combine the constant terms. So here 6c r minus 1 into 3 by 2 x square whole raised to 6 minus r minus 1. This can be splitted like this: 3 by 2 whole raised to 6 minus r minus 1 into x square raised to 6 minus r minus 1 into, here we have 1 by 3 into 1 by x. So we may split that like this: 1 by 3 whole raised to r minus 1 into 1 by x whole raised to r minus 1. Okay, now let's combine constant terms and x terms. So this can be written as 6c r minus 1 3 by 2 whole raised to 6 minus r minus 1 into 1 by 3 raised to r minus 1. So this is the constant term. Now x square terms, what we have here is x raised to, here we have x square raised to 6 minus r minus 1. That can be written as x raised to 12 minus 2r minus 1, that into 1 by x whole raised to r minus 1. Okay, now these three terms can be taken as a single constant term. So let's take it as k, and here we have two x terms. We may combine those two. So we may rewrite this one as k into x raised to, okay, so here we have 12 minus 2r minus 1. Here we have 1 by x raised to r minus 1. So 1 by x can be written as x raised to minus 1. Okay, so x raised to minus 1 raised to r minus 1. So that makes it x raised to minus r minus 1. Okay, so when we combine these two, we get it as 12 minus 3r minus 1. Okay, so if this is the constant term or the term with the power of x equal to 0, then this quantity 12 minus 3 into r minus 1 should be 0. Okay, so this expression or general term k into x raised to 12 minus 3 r minus 1 to be the constant term, what the condition to be satisfied is that 12 minus 3 r minus 1 should be 0. So for this to be the constant term, 12 minus 3 into r minus 1 should be equal to 0. So it means that 12 is equal to 3 into r minus 1, or it means, okay, if you cancel 3 from both left hand side and right hand side, here on left hand side we will get 4. So r will be equal to 5. So the fifth term in the expansion will be the constant term. So here answer is option C. Problem number 3. Find the middle term of x by 3 plus 9 by whole raised to 10. So we are asked to find out the middle term in the expansion. Okay, so here n value is equal to 10, which is even. Okay, so therefore middle term will be n by 2 plus 1th term. Okay, so if n is even, then middle term will be n by 2 plus 1th term. So here n value is 10. Okay, so therefore 10 by 2 plus 1th term will be the middle term. So that means the sixth term in the expansion will be the middle term. Okay, now we know that the rth term in the expansion is given by nc r minus 1 x by 3 whole raised to n minus r minus 1 into 9y raised to r minus 1. Okay, so here n value is 10 and r value is 6. So the sixth term will be sixth term will be 10c. When we substitute r equal to 6, we get 5 here. So 10c5 x by 3 whole raised to, n value is 10, r value is 6. So therefore 10 minus 6 minus 1. So 10 minus 5. So that is 5 into 9y raised to 6 minus 1, that is 5. So here answer is 10c5 x by 3 whole raised to 5 into 9y whole raised to 5. So that is given by option A. So answer is given by option A. Now let's see problem number 4. Term containing x raised to 6 in the expansion of 2x plus 1 by 2x whole raised to 20 is. Okay, so here we are asked to find out the term containing x raised to 6. Okay, so we know that the rth term in the expansion, is 20cr minus 1, 2x raised to 20 minus r minus 1 into 1 by 2x whole raised to r minus 1. Okay, now here let's combine constant terms and x terms. Okay, so here we may rewrite this term as 20c r minus 1, 2 raised to 20 minus r minus 1 into 1 by 2 raised to r minus 1 into x raised to 20 minus r minus 1 into 1 by x whole raised to r minus 1. Okay, so this part comes as a constant term. Let's take it as k. Now x terms, okay, we may rewrite this as x raised to 20 minus r minus 1 into 1 by x may be taken as x raised to minus 1. Okay, so x raised to minus 1 whole raised to r minus 1. Okay, so it can be rewritten as k into x raised to 20 minus r minus 1 into x raised to, so here we have minus 1, that into r minus 1, so that makes it x raised to minus of r minus 1. Okay, so when we combine this, we will get it as k into x raised to 20 minus 2 r minus 1. Okay, so this is the general expression. Okay, so for this expression, if it needs to become the term containing x raised to 6, then this quantity what we have here, okay, that must be equal to 6. Okay, so using that condition we can find out the r value. So if 20 minus 2 r minus 1 has to become equal to 6, then the r value must be, okay, we can calculate like this. So take this term to the right hand side and take this 6 to the left hand side. So we will get 14 on left hand side, 14 equal to 2 into r minus 1. So this implies that, okay, if we cancel 2 from both left hand side and right hand side, here on left hand side we will get 7. So 7 equal to r minus 1, it implies r value is equal to 8. So it will be the 8th term which will be having x raised to 6 in the expansion. Okay, so here the right answer is given by option C. Okay, now let's move on to problem number 5. If coefficients of x raised to 7 and x raised to 8 are equal in the expansion of 2 plus x by 3 whole raised to n, then n is equal to. So we are asked to calculate the value of n. The hint is that the coefficients of x raised to 7 and x raised to 8 are equal. So we know that the rth term in the expansion will be nc r minus 1 2 raised to n minus r minus 1 into x by 3 whole raised to r minus 1. Okay, so if r minus 1 value is 7, okay, then that term will be having a power of 7 corresponding to x. Okay, so if r minus 1 is equal to 7, then the term will be nc7 2 raised to n minus 7 into x by 3 whole raised to 7. Okay, so this term will be having x raised to 7. Okay, and now if r minus 1 is equal to 8, okay, then the term will be nc8 2 raised to n minus 8 into x by 3 raised to 8. Okay, so it is said that coefficients of x raised to 7 and x raised to 8 are equal. So we may expand this term like this: nc7 into 2 raised to n minus 7 into, here we have 1 by 3, so that constant term we can take outside, 1 by 3 whole raised to 7 into, okay, then what is left out is x raised to 7. So this is the coefficient of x raised to 7. Okay, now this term can be expanded like this: nc8 2 raised to n minus 8 into 1 by 3 whole raised to 8 into x raised to 8. Okay, so let's see the coefficients. So here coefficients are, okay, so this is the coefficient of x raised to 7. Okay, and this is the coefficient of x raised to 8. Okay, the coefficient of x raised to 8 is this one. Okay, so this is the coefficient of x raised to 8. Okay, so it is said that coefficients are equal in magnitude. Okay, so let's equate those two. So nc7 into 2 raised to n minus 7 into 1 by 3 raised to 7 is equal to nc8 into 2 raised to n minus 8 into 1 by 3 raised to 8. Okay, so from this we may calculate the value of n. Okay, let's see how to do that. So what we have is nc7 into 2 raised to n minus 7 into 1 by 3 raised to 7 equal to nc8 2 raised to n minus 8 into 1 by 3 raised to 8. Okay, so nc7 may be written as n factorial divided by 7 factorial into n minus 7 factorial. Okay, now here we have 2 raised to n minus 7 and here we have 2 raised to n minus 8. So we may replace that with a 2 on left hand side, because here we have 2 raised to n minus 7 and here what we have is 2 raised to n minus 8. So if you cancel 2 raised to n minus 8 from this, left out value will be 2. Okay, so that 2 we are writing here. Now here we have 1 by 3 raised to 7 and here we have 1 by 3 raised to 8. Okay, so if we cancel 1 by 3 raised to 7 from this one, we will be left out with 1 by 3 here on right hand side. So here we will have 1 by 3. Okay, so here on left hand side this will be the term, that one is equal to, here we have nc8, so it means n factorial divided by 8 factorial into n minus 8 factorial, n minus 8 factorial into 1 by 3. Okay, so let's cancel common terms on both left hand side and right hand side. Okay, now here we have n minus 7 factorial and here we have n minus 8. So if we cancel n minus 7 factorial, sorry, n minus 8 factorial on both left hand side and right hand side, here we will be left out with n minus 7 and here we have 7 factorial and here we have 8 factorial. So if I cancel 7 factorial from 8 factorial, I will be left out with 8. So once we simplify, what we get is 2 divided by n minus 7 equal to 1 by 24. Okay, so that will be the simplified form. From this we may calculate n value. So this is, okay, 2 into 24, 48 on left hand side equal to n minus 7 on right hand side. This implies that n value will be equal to 48 plus 7, that is 55. Okay, so the right answer is n equal to 55. So here the right answer is given by option A, that is 55. Okay, so with this we are coming to end of lecture 7. In lecture 8 we will continue with binomial theorem. We will discuss identities of binomial theorem, the greatest coefficient and properties of binomial coefficients. So for upcoming videos you may subscribe to our YouTube channel Vadhyar Online Academy, and for study materials you may join our Telegram channel using this link. So see you in lecture 8. Goodbye.